Chapter 2 comprises of two separate topics, Rayleigh flow and Fano flow. Now, Rayleigh flow is flow through a constant area duct with heat transfer without friction is called as Rayleigh flow. But Fano flow, it is also flow through constant area duct but with friction and without heat transfer and work transfer. This is called as Fano flow. I depicted this picture here. Then next is to remember this Fano flow, we have one shortcut. Fano first letter is F and friction first letter is F. So remember this. Fano stands for friction. If flow is Fano, there should be friction. This is the topic we need to discuss in this chapter 2. Now we have one formula for Rayleigh flow. It is P2 by P1. This P2 by P1 is equal to 1 plus gamma m1 square by 1 plus gamma m2 square. This is the ratio between the pressure at section 1 and section 2. And I depicted this picture for a straight duct. This duct, this is section 1 and section 2. We will call it as P1, T1, C1, A1, M1 for section 1. For section 2, we will call it as P2, T2, C2, A2 and rho 2. So these are the parameters we are going to use for solving the problems, both Rayleigh and Fano flow, right? If they gave the Mach number m1, it is very simple, or if they didn't give any number for the speed ratio, that is a Mach number, then you need to solve by formula m1 equal to c1 by a1. They didn't give the Mach number, then you need to solve by formula C by A, M equal to C by A. For section 1, M1 equal to C1 by A1. For section 2, M2 is equal to C2 by A2. If they didn't give value of A2, then you can find by root of gamma RT2. I depicted that picture also in my background. So see this. If they didn't give the value of A1, then you have to use formula root of gamma RT1. Simply A is equal to root of gamma RT we discussed in our first chapter. Next is heat transfer energy equation, heat energy equation Q. M is equal to Cp into delta T naught. This is a equation for heat energy in terms of watts. In Rayleigh flow, stagnation pressure T02 is not equal to T01 always. And next formula is impulse function F2 by F1. F1 it's the ratio of section 1 and section 2's impulse. Similarly, we gave a formula for the ratio of pressure P2 and P1, we gave it already. Similarly, for stagnation pressure P02 and P01. Similarly, static pressure T2 by T1. Stagnation pressure ratio P02 by P01. So these are the ratios we gave, but using this formula, we need to solve the problem. We have on a flow chart. This is change in entropy del S. S2 minus S1 by R is equal to ln of M2 by M1 into M2 by M1 of 1 plus gamma M1 square plus 1 plus gamma M2 square whole power of gamma plus 1 by gamma minus 1. This is the equation I depicted this picture here. Then I gave another equation relating Qmax. Qmax is a maximum heat transfer. These are the equations we are seeing, but simply using this equation we can't get full flow of problems. Right now we need to solve by separate steps. We have some steps to solve the problems. Here the first step is, if they didn't give the Mach number for section 1 or section 2, now let us assume they are giving some data about section 1 and we need to find data about section 2, right? This is a straight duct. Now we need to solve this T01, P01, T1, P1 by using gas tables. And next step is for section 1, you need to find Mach number, then with the same Mach number find P1 by P1 star, T1 by T1 star, P01 by P01 star, T01 by T01 star, C1 by C1 star. This should be used in your Rayleigh's tables. This formula, these ratios can be found in your gas tables in Rayleigh, in the Rayleigh table. P1 by P1 star, T1 by T1 star, P01 by P01 star, T01 by T01 star, C1 by C1 star values can be determined by using your Rayleigh table. Then using this Rayleigh table, these ratios, then find the value of T1 star, P1 star, P01 star, T01 star, C1 star. If needed, then you may find. Right, now we have to find the value of M2 by using this values. By using this flow chart, you can find M2. Then for the respective Mach number, and the next step is to find M2. How we can find M2? By using these values. Right, now we know P2 is say for example P2 is given. Now it is a time to find value of M2. Now how can we find M2? If they gave value of P2, then find the ratio of P2 by P2 star by using your calculator. Use your calculator to find the ratio of P2 by P2 star, then find the respective Mach number M. This is M2. Now we found M2. Now the problem is solved. Now you can find the value of P2 by P2 star using your Rayleigh table. Then you can check your answer with flow is isentropic. You can get the result of T02, P02, C2, even T2. You can find the section 2's parameter completely. This is a procedure to solve the problems. And next is some common formulas used in your problems. Delta P0. Delta P0 is P01 minus P02. And next is to find stagnation pressure ratio loss. Stagnation pressure, maximum stagnation temperature is given by T0 max. It is given by T01 star is equal to T02 star. It is also equal to T0 star. This is a common at the throat section. If they didn't give R value, then you can find by Cp into gamma minus 1 by gamma. Similarly, we depicted the picture for del H0. It is calorific value of fuel by air fuel ratio plus 1. This is a formula for del H0, and you can use this formula also for del H0. It is del H0 is equal to Cp into T02 minus T01. Density, it is found already. And next is density. Density is rho. Rho is equal to P by RT. For section 1, rho 1 is equal to P1 by RT1. Rho 2 is equal to P2 by RT2. And for heat energy, Q is equal to mCp into delta T0. If symbol is negative, then it indicates heat is leaving from the system. And next is fan of flow. This is the second part of your chapter 2, with friction, without heat transfer, without work transfer. In our given data, friction factor F bar is given. If the data F bar is given, then this problem is coming under fan of flow. And this picture depicts common steps for solving the problem of Fano type. Right, now for the same straight duct they gave for section 1, they gave the Mach number M1. Then you need to find the value of T1 by T01, P1 by P01 for flow is isentropic. For section 1, you need to find the value of T1 by T01, P1 by P01. Flow is isentropic using your isentropic tables. For the same Mach number M1, you need to find P1 by P1 star, C1 by C1 star, T1 by T1 star. Similarly, P01 by P01 star, 4F bar L max by D using your Fano table. Use your Fano table to find these values. Then you need to solve for M2. This is the next step. See this picture from P1 by P1 star, C1 by C1 star, T1 by T1 star. Right, now you need to find the value of P0 1 star, P1 star, C1 star, C and T1 star, P1 star, C1 star and T1 star, also P0 1 star. Now you have to equate it with P0 1 star is equal to P0 2 star. Now equate this, then find value of M2. For M2, find all the data of C2 by T. Find for M2, find all the data of C2 by C2 star, T2 by T2 star, P02 by P02 star, 4F bar L max by D. Find all the data for section 2. And the final step is find the value of 4F bar L by D using this formula. They gave friction factor. Then you can get the value of distance L. This is the L. It is the length of the duct. You can get the length of the duct, where L is the length of the duct. And another one important formula is del S. S2 minus S1 by R is equal to ln of P01 by P02. This is the formula to find del S, that is change in entropy.